This is a normal distribution. A lot of the analyses you'll perform assume that our data is shaped like this, with most of the scores clustered around the centre and fewer scores out at the extremes. When a dataset is perfectly normal, note that this is super rare, our mean, median and mode will all be the same. So say we have a group of 9 adults and we measure the length that they can throw a javelin in metres. In a regular group, you'll assume that some people can throw longer distances and others shorter, but most people will land somewhere around the middle. So here were the distances for our sample. Our mean is calculated by taking the average, so 270 divided by 9, giving us 30. Our mode is the most frequent score. In this case, we had 3 javelin throwers all throw a distance of 30 metres. Our median is our middle score, so if we count along, in the middle of our 9 scores lands 30. But what happens if one of the adults is a professional javelin thrower and they throw an extremely long distance? As you can see, this gives us an outlier, a score that is far more extreme than the rest of the scores. Because the score of 58 is particularly high on our scale of javelin distance, the tail of our distribution is dragged in a positive direction, and we get what is called a positively skewed distribution. Now our most common score is still 30, and our middle score is also still 30. But because our mean is calculated by taking the average, this time we have a total of 288 divided by 9, giving us 32. So the mean is dragged up because we have this extremely high score at the high end of our distribution. But what happens if instead of a professional, we have a child come and throw the javelin? Being smaller, the child throws a much shorter distance than the adults, so we now have an extreme low score. So this time, because of the score of 2 or 2 metres being particularly low on our scale of javelin distance, the tail of our distribution is dragged in a negative direction, and our distribution becomes negatively skewed. Again, our most common score is still 30, and our middle score is also still 30, but this time our extreme low score of 2 drags our mean down. So to look at a distribution and quickly determine its skew, look at the tail. If your tail is dragged up on the right with the higher scores, you have a positive skew. If your tail is dragged down to the left of the distribution with the lower scores, you have a negative skew.